For each one of these figures that I have a rotational symmetry for, all of them, I will tell you up front, are all regular polygons. So what I'm going to do is I'm going to draw a center point here, and I'm going to draw out to each vertice, and I am making what we call central angles. And I'm going to let you know how to find the measure of each central angle. So now remember, if I make a rotation of the central angle, so if I rotate from here to here, I will still have the same figure. So each rotation could give me the same thing. I could either rotate it just a little, or I could rotate it twice as much. So how would I find that? Well, I'm going to count out the number of sides, or the number of, remember that the number of sides will also be equal to the number of central angles. So I could count either the number of sides or the number of central angles. Nonetheless, I have 1, 2, 3, 4, 5, 6, 7, 8. So how can I find the measure of each rotation to keep the figure the same? I would do 360, that would be all the way around, divided by 8. And when I punch that into my calculator, it gives me 45 degrees. So any rotation of 45 degrees will give me the exact same figure. What about a triangle? I draw to my 3 vertices. I have 1, 2, 3, so I do 360 divided by 3. That gives me 120 degrees. Don't forget that degree sign. Now let's look at this one. 1, 2, 3, 4, 5. So I'm going to take 360 and divide that by 5, and that gives me 72 degrees. Okay, any rotation of 72 degrees or multiple of 72 degrees will still give me the same figure. And here I have 1, 2, 3, 4, 5, 6. So this would be 360 divided by 6, which would be 60 degrees. Any rotation of 60 degrees or a multiple of 60 degrees will give me the exact same figure, and that's why it's called rotational symmetry. I still wind up with the same figure.